filament loading, just we will go for the filament loading, then it will first of all reach the particular temperature that is set like 230 degrees Celsius. Then only the filament loading will begin. So since I have just to save the time, I have already loaded the filament, so I won't be hitting it. But that we will go to the part printing. So this is the print option. Then we will see get into the directory of this printer. Then from which part we have to print, then we can go there, and then we will save the particular file and just click the print option. And see now the printer will automatically calibrate itself and choose the nozzle which we have selected, and then after reaching the set temperature, which here we have set as the 230 degrees Celsius and the platform temperature at as 105 degrees Celsius. So before reaching that particular temperature, the printer nozzle will wait for that like 105 degrees Celsius and 230 degrees Celsius for the extruder, and then the printing will begin. So it will basically take I mean 5 to 10 minutes. So meanwhile, I think we should wait. While the bed is heating up and the nozzle is heating up, I think I should move further with the DFT printer. Hello. So while the printer is heating up, like the bed will reach up to 105 degrees Celsius. So I think without wasting time, we should move further with the DLP printer and about its introduction. Like what is DLP printers? Because I think we have all of you all have been already introduced about the DLP printers. So let me share the. So should I move to the introduction of DLP printers, because it will take time to heat up the raise the temperature.
Yes, please proceed. Yeah, you can take DLP and then demonstrate a video of the machine, etc.
Yes, yes. Yes, so this is the Anycubic Photon Mono X 4000K DLP printers we have in our lab. Everyone must be aware what is DLP printers. It is basically a kind of resin-based UV cured 3D printer, wherein unlike FDM printers, where we use filaments to fuse the filament, and then the bed moves in the Z directions to print. Herein, there is no any kind of filaments we use. Here, basically, we use UV, like you can photosensitive resins, which basically solidifies upon exposed to the UV lights, right? So here it is you can say like unlike FDM printer, it is very hectic or kind of printing, wherein you get cumbersome process actually, like the resins get stuck to your hand and all. So I'll show you all in the next section. So basically, it uses UV cured resins, which is stored in this particular, you can so storage tank. You can see here, this is the storage tank wherein you will pour the resin UV based, and then these are the interfaces wherein we can control the intensity of the resin as well. And then this is it. One thing you should note that in all the UV, or you can say laser based 3D printer, the Z direction moves to the minus, from top to bottom, sorry, yes, from top to bottom, but particularly in DLP printers, the bed moves from bottom to top, right? Why? Because here the queuing system is at the bottom, unlike the lasers in other DLP or laser based printers. So these are the certain parts we have developed in our lab. This is basically keyrings, movable keyrings of our college with the hologram over here. So these are the features of current 3D printer. Like exposure is screen is 9.25 inch of monochrome. Then printing volume, here we have 245 into 197 into 122 mm. Then the light transmittance is 6% in contrast ratio. Light source is parallel matrix LED. So there is no laser source here. You can see, if you can see, then this all reason is basically a screen like mobile screen, LCD screen, and beneath that there is source of monochromatic UV rays light. So each time a particular pixel is illuminated, and that due to that illumination of particular pixel, you can say the that particular file gets cured, and subsequently layer by layer, the pixel by pixel, the part is cured and it made into 3D printed parts. So this is the you can say warning introduction for the DLP printers, especially. Why? Because the UV resins are very sensitive and it may sometimes cause skin irritations. So wear PPE because this includes nitrile gloves, which is already comes with the printers. Just again, you have to take it. Then sleeves as well as safety glasses. The safety glasses will help you if you accidentally spill the resins, which is quite possible because it has happened with me as well. Again, we have to ventilate the area. Photo resins can evaporate into the air and you could be breathing the chemicals. And this will hazard filling. Then clean the equipments and workstation because ultimately you will end with the lots of dirts and liquids on the table. So you will inevitably stop resins, and cleaning up it quickly will avoid data exposure. So there are certain advantages of DLP apart from FDM printers. Like parts with detailed structures can be manufactured with crisp edges covering minutes and details. Why? Because unlike physical movement, here we have you can say light-based resins. Printing speed is relatively higher due to the usage of digital projector light when compared to other bad polymerized techniques such as SLS, centering. Then intensity of the light source can be controlled by the operator. This we can manually control using the interface provided. Then DLP produces objects that are super accurate with clearly structured geometry. I will show you some of the intricate parts we have developed in the coming slides. But yes, again, there are certain disadvantages like the manufactured model should not be exposed to sunlight. Why? Because the color gets paled. Means the color gets very yellowish, and it may break up the parts. It means it becomes very brittle when exposed to the sunlight. So this is the main limitations of this parts. Apart from that, the parts are so strong if until and unless it is not exposed to the sunlight, and thus it cannot be remodeled or modified. The third is like DLP 3D printers run with more cost because its initial cost is very high, as well as you can say the resins which cost at least 2 to 3,000, while the FDM filaments cost only 7 to 800. So just they are very the UV resins are very costly, and again you will waste most of them during spillage and all. So yes, this is very costly printer as compared to that. So this is a printer we are having. These are some parts we have printed, like the pendles. And this is the key sample we have printed, and inside that there is written. So one of the keyest feature you can say, like unlike FDM printers, we don't have to provide any support structures over here. Can you give us a reason that why there is no support structure required? If anyone interested to say, what is that? Anyone from the participants? Why support structure is not required over here? No one. Well, we'll see later if no one will give the answer. Then again, see the you can say the fineness or the surface quality. The layers even are very smooth, and it is not visible by naked eyes. While with zooming or zoom lens, we can see the layers. So this is not possible in case of FDM. There, the layers can be visible by naked eyes. Like you can see here, you can see the naked with naked eyes the layers. These are the layers of the printed parts. And yes, these are the DLP printed parts like pendles. You can see you can't see the layers by naked eye. See if you can find it, you won't be able to find it. Then again, these are the parts I have shown you already. Uh, this Voronoi diagram rabbit and this cube with no support within it. And thank you. These are some pictures from our lab visit from CMM while designing these parts. So with this, I think the temperature has yes, the printing has started there. So I'm sure. See what the temperature has reached, the printing has begun, and the nozzle is moving into the predefined path. Shading strong. It creates one part, so it is not visible. This is the process after reaching the temperature, like the temperature has been reached over here. You can see like 105 and 30, and then only the process will begin. This is the basic steps involved in 3D printing using the printers. And for DLP printers, we have this short video for you because it is installed somewhere else, and then I have to switch off the camera. So here in video, you can see the working of DLP printers. See, the UV lights is curing layer by layer, and accordingly, the platform is moving up. See, at this position, the UV light, see the parts has been printed. So the parts have been printed there, and see the laser is curing the next subsequent layer, and then it will again raise to a particular height, like say 0.1 mm or like that, and then subsequently the part will be printed. These are different parts I have already shown. And, I think that's it now. And,
Sir, in the given figure, top right, why there is no support required? You didn't answer.
Yeah, so I was expecting that answer from the participants. I hope you could try, because we have been learning about additive manufacturing since I think 1 week. So can you please give me an answer like why there is no support structures required over here? Hello, are you there?
Yes, sir, but I could not answer, sir.
That's fine. Uh, Basically, it is a region based, no? So the you can say like the entire volume is filled with the resins. See over here. So there is no overhanging area or parts which will be hanged in the air while printings. Uh, like in this case, inside it is hollow. But what happens during DLP printers? It moves from this position to that position. Then what happens at this part when the printer tried to print over here? Then in the entire area, the resin is filled. So ultimately, the structure is supported by the resins. So that's why it doesn't require the support structures. While in FDM printers, since it is completely printed in the air, so there is no physical support upon which the inner surface will rest. So in that case, the support structure is required. I think I answered your question.
Yeah, thank you so much.
So for this, for example, if you take FDM, there is some limitation for some angle. After that, we have to go for support. So this process, you can make any angle. That's what you're saying.
Sorry, sir, can you please repeat?
For example, if you go for FDM process,
Yes, sir.
so is it my voice is audible?
Yes, sir. It is audible, sir. Please continue.
Okay, so if you go for FDM process,
Yes, sir.
maybe if you go for beyond certain angle, you have to go for support.
Hmm.
But this process, no need of any support for any.
No.
If you go,
You are
yeah,
saying that for this particular post like DLP, you don't need support. Are you asking
yes,
this?
sir.
No. It
Yes,
is
sir.
not. It is not always true, because some parts which like suppose this is the part, fine. So if you wants to make certain kind of like overhanging parts at the end, I mean at the end of the structure, like over here, then just for the easy removal, or you can say just to avoid the you can say warpage or breaking of the parts while removing the parts from because you have to use such kind of a spatula to remove the part from the platform. So if the part is very intricate and very thin, then while removing, then definitely you will end up breaking the parts. So in that case, it is tilted like 30 degree or 20 degree from the base. Like suppose this is the building platform, see here, then you have to just leave it like this, like 30 degree, 20 degree, and then support structures is generated between the base surface and the base, so that since the support structures are very weak, because they are hollow structures and very thin, like 1 mm or 0.5 mm of thickness, so that could be easily removed in that particular case. So you can say like in many it will particularly depend upon the application, like where you have to give supports or not, but generally or mostly you can say that the support structures not required in FDM, sorry, in DLP parts.
Okay, sir.
Hope sir I have answered your query, sir.
Okay, sir. Thanks.
Thank you.